Good evening, everyone. So we are doing today we are doing dynamic programming series. So let's see dynamic programming series. So there is a common pattern we can see in the dynamic programming. Let's see some of the patterns. So simply dynamic programming is divided into many 6 to 7 pattern. So there is one for the level one. We simply see this type of pattern only. So first type is linear DP. After you completing the linear DP, we see the problem on two-dimensional DP problem. Okay, and the problems on DP on grids. DP on grid. Okay, DP on grid. So covering the DP on grid, a common problem knapsack problem. Knapsack problem of DP. Knapsack problem of DP. Okay, knapsack problem of DP. After that, you see longest, increasing, subsequence problem. Subsequence problems. Okay, longest common subsequences problem. Longest, not direct question, but kind of similarity on this pattern. So longest common sequences, subsequences. Okay, after that DP on string, okay, and cumulative sum or multiple chain, and not that much cadence algorithm. So cadence algo. Okay, so for the level one, this is a level one topics, the similar common pattern in the dynamic programming. So linear DP, many you have solved many problem on linear DP like climbing stairs, a decode way, house robber, coin change. Only one thing are changing: delete and earn, arithmetic slice, all the things. So in 2D DP, the two things are changing. So coin changes, night dialer, a triangle, student attendance, K reverse pair, combination sum, largest sum, average, log jump, uh, buy sell stock problem, penthouse, DP on grid like unique path 2, minimum path sum, maximum number of product on matrix, maximum difference score, dungeons game, cherry pickup challenge, cherry pickup 2, out of boundary path, minimum falling time. So So today we discuss DP on string, and after that we move for the DP on grid. So let's see DP on string problem. So DP on string, DP on, okay. So we have to solve 3 to 4 problems. So after that we understand the problem on this. So here's the first problem. So we have to firstly we have to solve the problem like number of way to form a target string in given distance. So first one, maximum substring partition of equal. So mean substring partition of equal character. Okay. So mean substring partition of the equal character. First question. So let's search on Control A, Control C. Tab number 2. Mm, let's see the problem. So given a string S, you need a partition into it one or more balanced substring. For example, if S is given at A B C D, A B A B C C, and the A B A B A B A B C C A B A B C C and A B A B C C are the all valid partition, but A B A B C C A B A B C and etc. are not, because the unbalanced substring are bolded. So return the minimum number of substring that you can partition S into. So balance the substring in balanced string is a string where each character in the string occur the same number of time. So we have to do partition. Okay. So we can, for example, that A B F A B double C double D G. So we can partition the string S into three character in one of the following way is F A B double C double D and G, or F A B C C D and D G. Given string, you need to partition into one or more balanced substring. For example, S is partition 1 to 1. Okay, so A B all thing are valid partition, but A B A B double C are not. Why not? Unbalanced substring are bolded. A balanced substring is a string where each character in the string occur the same number of time. Substring each time substring occur. So A no time, C occur two times. So F is B. Well, so minimum number. So minimum and maximum minimum number of substring that can you partition. So minimum number. F A C F A C. Mm, B double C. Mm, so F A B double C double G. F A B double C double D. So in double D is given. So we have to do partition. So we have to do partition so that it becomes so how many so minimum number of substring that you can partition into substring minimum a 2 3 partition those. So each A occur two times. So in this B occur, if A occur two times, so B occur two times. So C occur two times. So we have to partition the string into a equal part. So if the target is partition the string so equal number of partition. So if we partition F, so rest of A B C C D D G. So see the difference. If F is 1, okay, this one is a balanced partition, but in A occur one time, B occur one time, C occur two times, so it is not a valid partition. So we do partition here. Okay, so F A B, so A B is valid one, C C, so C occur two times, this one, so this one, yeah, so this one is a valid partition, but size the size become the number of substring become 4. So this is try to reduce and try to minimize one. So in this occur one time, this occur one time, so we simply F A B and partition C C D D two time and G1 is separate. So minimum to minimum we have to do three partition. so it become a balanced substring. So the question is clear. So either we have to include or not include. So the question is some overlap based on the overlapping problem. So at each of the character, each character we have to choose whether or not. So if we include f or not, if we don't include f, so what is the further tree diagram? So maybe let's draw tree diagram for this, if it possible or not. Control C, try to make tree diagram. So mm, f, okay. So first, if we take f, okay, if we don't partition after a, so after a it becomes fa, and if we include b also, fab, what if include we include fabc, fabc, like that. Similarly, like that, f is rest of another one is a not partition equal. We have to check is valid or not. So like this, the tree diagram goes. So try we understand the basic problem. So we try to write the code. So and we have to return the number. So mm, so int n is equal to size dot size. Okay, dp1. So we can only partition. So simply no need to do that much. Simply we have to return the solve function. Return the solve function. So in solve function start, we pass the string and we have to pass from the starting index. So okay. So write for the next int solve function, or string is given. The string s and starting index is I. Okay. So write the base case. Okay. So write the base case. uh, int n is equal to okay, as dot mm, as dot size. Okay, as dot size. Okay, and become as dot size. So okay. mm, so if we reach I is equal to n, then we did not partition anything, so we have to return 0. So each time we have to count, how much element in our substring. So let's initialize and answer as minimum. So int we want to minimum, so int max. So map for create an order map like this. So okay, in each time we have to push the element into map and check this element is balanced or not balanced. If balanced, we move for the next one. If not balanced, we leave it. Okay, so run the loop. Int j is equal starting from the I index. So I 0 1 So 0 I2 is our next one. So j less than n or I plus plus. Okay, j plus plus. Each element we have to check. Okay, first of all, if element so we firstly add the element character. Okay, and check. We have to check if MP of S of J is MP of okay, that MP is actually that map is balanced or not. If balanced, you have to return the minimum value. So mean of answer plus what? 1 plus you have to move forward. So solve function to move forward. So move forward S or I plus 1. Okay, S and I plus 1. So inside solve function J plus 1. So S or J plus 1. Okay, move for next one. Okay, and if all these are correct, so simply return answer. How we check how we check our string or balance or not. So each time we are adding inside the map, are we checking the map are valid or not. So let's let's uh, let's make a map function to check yes or no. So answer, so we have to write ch check. So inside this a map, so map is given, so map mp int comma int mp at rate mp at the rate mp is passed. Okay, is passed. If we if we mp dot size, if mp dot size is 0, mp dot size is equal to this means that empty map and the this one is balance 1, so we have to return true. In this case we have written true. Okay, and we have to check the first element and the second element. So first element is equal to nums dot begin and its frequency become first element dot second. So through auto frist, first one is equal to mp dot begin is the first one. Okay, and its frequency will equal to what? First one dot second value. Okay, which we see the frequency. So then run the loop auto function auto at the rate in which element is there and its frequency is given. So over what? Over mp. Okay, if frequency is not is equal to this one, then this case in this minute return false. Okay, otherwise return true. False, return false. Return solve function we have to check. In this case we are running if map dot size return true or try it mp dot begin. So begins first element is equal to this. So auto function run on each loop if frequency is not matching with everyone's frequency. If f1's frequency, because it we are checking the order map now, each time we are add the element. Okay, so let's see. So each time draw So each time if we consider f1, so the map in f1, okay, f, so we're taking this one. So see, we put the value on c 2 time, d is equal to 2 time, okay. So we firstly take the first value, so first value is equal to c and its frequency become 2, so this value is taken. So after that we run each run on the mp map, run the loop on the mp, okay. So we have to check if frequency is not matching with the we earlier check the frequency, then in this case we have to return false, okay. If this condition is true, that means all of having the same frequency, a same frequency element, mean that same frequency mean that the string is balanced, okay. So in this case the string is balanced, so simply we are checking this, or the answer will be this. So we are so let's memorize, simply we have to memorize. So the string length will be more than something, 1000. So try to write memset one, mm, memorize memset dp of size of -1, -1, uh, size of dp, okay. Let's initialize the length will be 100, so we initialize being 1001. So int dp 1001, okay. mm, okay, solve function I changing if dp of I is not is equal to -1, this means already calculated, so return dp of I, okay, and store this value dp of I is equal to this one. So we have to check correct and submit. So checking function is very crucial, and here we things clear. S of I is clear. So in J we start with the J plus J, okay. We start with the J, okay. All thing is sorted. Mm, all things are sorted. So okay. So let's move forward for the next question. Mm, so we are applying the DP on the string. So as we see, so after that, a word break problem. Word break lead code. So word break problem. Okay. So in this question, given a string s and the dictionary of the string word dictionary, return true if s can be segmented into the space of one or more dictionary word. Simply overlapping problem. Okay. After watching the question, we simply see that this one is a DP based problem. So next question we are doing. So we have to make a segment. So this one here we have to. It's a word break problem. So um, word uh, word break problem. So in this problem we see that a given string s is given just like lead code, okay, and the dictionary of array is given just like lead and code is given there. So we have to return what we have to return uh, return. We have to return true or false if this if the string segmented part is exist in word dictionary or not. Like the apple is existing, pen is existing in this one. So return true because the apple can segmented as the apple, pen, apple. So note that you are allowed to reuse the dictionary word. Okay. If it exists, we have to return true. Then it yes, we false. So okay. So cats exist, sand exists, dogs exist. Then false. So why this one? Cats exist. Okay. Space and exist. OG is not existing. So apple, pen, apple are existing. So the cat exists, but also and exists, but OG is not in this dictionary. So I have written false. So in my mind, the only thing is coming that so if L mm, like this we have seen.